Hello, my name is Chris Olsen. I've been judging science fair for over 10 years, and I will go over my impression of certain projects using ACSEF's Rubric. Our rubric we use to judge posters is 20% creativity and originality. That will come out to be 2 points on a 10-point scale. We use 1.5 points or 15% for design and methodology. Typically, we're looking for maximum control of variables, moving to quantification rather than qualitative assessment, and minimizing uncontrolled variables. 2 points or 20 points on a 10-point scale are its execution. We're looking for enough data points and repeats, as well as a reference line that we are used to judge the improvement in the project, as well as graphical representation. We're generally looking for XY plots or scatter plots opposed to line or bar plots, as well as a key graph that tells the story of the project. The poster board is 2 points or 20% on a 10-point scale, where we're looking for all the proper elements from beginning to end, as well as clarity in the explanation of a project. Sometimes some students actually have too much content. And the last one, which I won't go over too much in this recording, is the interview, which is 2.5 points or 25% off a 10-point scale, where we're really looking, does the student understand the science? Are they able to respond to questions? If they can, we give them the benefit of the doubt, whether it may be apparent that they got extra help from a parent or in a university lab setting. Really, the student understanding the science is the key metric, and we give them the benefit of the doubt in the interview process. If we look at this middle school science fair project, where the student was attempting to study the insulating properties of vacuum insulated mugs in a warm incubator, watching room temperature water rise. The first thing that we take away is that the student has used large fonts and clearly has laid out a research question and materials procedures. They have nicely separated controlled and uncontrolled variables. They perform a large number of measurements. They have a key graph, XY, where all the conclusions can be drawn, and the student has organized it well. If we zoom in, a key feature again is this: the student has thought about the design of the experiment to control as many variables as possible. If we look at the key XY at the bottom, there is a control. Another key factor in experiment is what are we comparing it to, and there is a clear separation, and we can find the best performing cup in the group. This project scored well. This concept of characterizing vacuum insulated mugs is a novel that had never been seen before, and in its feeder fair, this project scored very well for originality. This middle school project for vacuum mug characterization is extremely unique and has never been seen before, so it would earn a full 10 out of 10 points for creativity due to the clarity of the graphs and all the details within the poster, I would also give it a full 10 points. The execution, they took so many data points. Typically we're looking for 30 data points, full 10 out of 10 points, and as well as design and methodology. There was a lot of good control of variables as well as strong methodology in the characterization. I'd also give it a full 10 points. So this project would receive full marks, and I would recommend it to move on to second round due to its originality. If we move on to another middle school project, this is a propeller project. Propeller projects have been around, so it may score lower on creativity and originality. There's some interest in purpose, understanding propulsion time of this propeller-powered car versus propeller area. So they're kind of determining some key factors there. They have controlled and uncontrolled variables. The downside of this project at the middle school level is perhaps this transit time of this propeller-driven car versus propeller area has a non-linear relationship, which tends to be perhaps a little bit advanced past this middle school grade level. And again, you know, as a judge, you want to continue to drill the student and try and drive understanding maybe where their graphical representation is falling short. For this middle school project, propeller projects are actually not that unique. I would only give it 2 out of 10 points. The use of propeller area may be marginally creative. For the poster quality, I would give it 9 out of 10 points. It's a tiny bit of messiness, but other than that, almost full marks for the poster clarity. Execution, I would give 8 points. And design and methodology, the fitting of the line, the linear line to a nonlinear data graph, a bit complex for a middle schooler. But I'd only given 7 points, as well as there was only about 15 total tests and only tested 3 designs of area. So a few gaps there in this project. Due to the fact that it's not that original, as far as propeller projects are very common all over the internet, I would not recommend this to move on to round 2. If we move to another middle school project, here we were looking at different roasting time and roasting types to see if we could measure different acidic nature of coffee. Again, the project's well laid out, clear question, discussion of controlled and uncontrolled variables. The representation's clear. The pHs were measured across this. Occasionally, one of the key discussions to have is with their measurement apparatus. pH can be somewhat tricky, especially if using litmus paper. Typically, the resolution limit would be 1 significant digit, not down to tenths. Digital pH meters might get you to tenths, but again, might require multiple measurements, and that's a key factor. So this project wasn't actually able to separate the data very much. Most of the data kind of fell within a similar distribution, but it was somewhat original, but you know, probably struggled with the pH measurement accuracy. This middle school coffee roasting project, It's on the border of creativity. I might give it 5 out of 10 points for creativity. It's not really clear, measuring pH of coffee is really that unique. Most people know that coffee is acidic, and would not necessarily rank that high on creativity. The poster itself had a lot of clarity, actually well laid out, even artistic. I would give it a full 10 points for the poster layout. Execution was a little poor due to a lot of noise in the data, as well as not as much separation of the data points, and only, I think, 15 total data points. Design and methodology, I would give 6 out of 10. Again, the differences for this whole project was about 0.1 to 0.3 on a pH scale, which was pretty small and close to the signal to noise probably for all these testing methodologies. So it's scoring a little bit low in those areas for that type of reason. Again, the creativity and purpose is not strong, so I would probably not recommend this project to move on to round 2. And lastly, we have a high school project. For this high school project, often if we see some very complex project, the first thought is to engage the student with perhaps they did an internship in a college or university lab, and a significant portion may be spent drilling the student to understand how much they understand and how much they actually performed relative to a undergrad or even grad student that may have performed some of the research. One of the key things is, again, to focus on the student's understanding of these complex topics. And again, we're looking for the student to be able to explain this potentially to a layman that may not know this type of university level project. So clarity of that explanation and understanding to a layman is super important. Additionally, some students may try to overwhelm the poster with just excruciating amounts of data. So over use of very large poster boards could be a sign the student's attempting to cover up what they don't know by having lots of things to discuss. Usually what I'm looking for is the student to, again, simplify the material for the judge and to explain it to a layman. And again, zoom in on, tell me what the key features is, or tell me what the key learnings are, and you might even provide a time scale. Can you give me an elevator pitch conclusion in 30 seconds? And those types of, driving the student towards what did you do, what did the grad student do, and can you give me the clear conclusion, can really help a judge understand how much was done by professors and grad students, and how much was done by the student, and where was the student's contribution. This high school project on virus and vaccine study is probably the hardest to rank out of all this group, given that it is not within my area of expertise, as well as it's without a interview with the student is unclear on the level of originality on this project. So without being able to discuss with the student, I would rank it 8 out of 10 for creativity. Again, that's a little bit arbitrary at this moment at this stage. The poster, I would give a 9 out of 10. I would actually argue the poster is a little bit too crowded, and that is probably, there's a slight negative in the ability to make something more clear and concise. For execution, again, not even be able to interview the student. It looked like there was a lot of execution and data. I would give it 10 out of 10, give it the benefit of the doubt. Design and methodology, again, giving the benefit of the doubt, it's probably going to fall somewhere between 8 and 10. And whether to move on to round 2, at this point with no clarity, it's a maybe. For me, out of my area of expertise, it looks novel. I might rank it to a second round, but I might have to lean on another judge or through the questioning process to determine the level of originality to decide if it would go on to round two.